Wait, don't swipe past this. The next 6 minutes can literally risk your AP chemistry score. We're starting Unit 3 Intermolecular Forces and Properties, and this first topic, London Dispersion Forces or LDFs, is the foundation. If you get this right, the rest of Unit 3 feels easy. If you don't, you will keep tripping over boiling points, vapor pressure, and phase diagrams all year. LDFs are the weakest type of intermolecular forces, but don't underestimate them. They are universal. Every single particle, atom, ion, or molecule experiences LDFs. Even helium atoms, even nonpolar molecules like O2 or N2. Why? Because electrons are constantly moving. Imagine electrons like restless kids in a classroom. They never sit perfectly still. At any random moment, the electron cloud of a molecule can shift slightly to one side. That creates a temporary dipole, a momentary uneven distribution of charge. So it's called an instantaneous dipole. That temporary dipole then induces another type dipole in a neighboring molecule. Now they are attracted, even if just for an instant. The attraction is your London dispersion force. Here is the golden rule. More electrons equal to stronger dispersion forces. In AP language, we call that greater polarizability. Polarizability just means how easily the electron cloud can be distorted. Same group, all nonpolar diatomic molecules. Fluorine F2 is a gas, while chlorine is a gas too but heavier. Bromine is a liquid, iodine is solid at room temperature. Why is that? The only difference is the number of electrons. As you move down the group, the atoms get larger, the electron clouds get bigger, and London dispersion forces get stronger. That's why fluorine and chlorine stays as gases. Bromine turns into a red liquid, and iodine is a purple solid. Now, let's link this to a real exam question. On the AP exam, they love asking, why does one molecule have a higher boiling point than another, even though both are nonpolar? Your answer should be, because the molecule with more electrons has stronger London dispersion forces due to greater polarizability. Notice these two red phrases, more electrons and greater polarizability. If you include them, you are literally using the rubric's exact word. That means easy points. You don't just say butane is bigger. You say butane has more electrons and greater surface area, which leads to stronger London dispersion forces and therefore a higher boiling point. Let's pause for a second and connect the dots. LDFs come from temporary dipoles. Bigger molecules with more electrons have stronger LDFs. Greater surface area increases the strength too. These forces explain trends in boiling point, melting point, and physical states. If you memorize that chain, you have basically solved 80% of the Unit 3 multiple choice traps. Here's a quick rescue tip. On free response questions, always start with the phrase, London dispersion forces are present in all molecules. Then compare strength based on electrons, polarizability, and surface area. That structure makes graders smile because they don't have to dig through your answer to find the rubric words. And now, why does this matter? Because Unit 3 is a bridge between tiny particles and real world properties. When you understand why iodine is solid, why oil does mix with water, it doesn't, why helium liquefies only near absolute zero, you have unlocked the chemistry's logic. Alright, next video we are stepping up to dipole-dipole forces stronger than LDFs, specific to polar molecules, and a common trap in FRQs. Don't miss it, because you will see exactly how polarity changes everything. Stick with me, 5 short videos a day, and we will get you to that 5 that you are looking for.